Okay, 10F2, question 7. This one you need to read quite carefully. A little bit confusing. It says the second term, it's about this term of a convergent infinite series. So that they're saying you've got T1 plus T2 plus T3, and this is your series. They're talking about this term is 8 fifths, right? Not T1 plus T2 equals 8 fifths. Okay. So that's the confusing bit in this question. The sum of the series is 10. We know that the R value is smaller than 1, or modulus R. Okay, so let's write that information down. We're doing exercise 10F2, question 7. We know the second term is 8 fifths. Our expression would be T1 times R to the n minus 1. But I know that that is just R to the power of 1 because n is 2. So it would be T1 times R equals 8 fifths, right? That's R to the power of 1. And they've told me that if I do this sum infinitely, the answer gets to 10. So my infinite series formula looks like this. And the answer to that is 10. Okay, we could rearrange this one and say T1 equals 10, 1 minus R. Although maybe it's easier to rearrange this one. I'm not sure. Well, I've done this now, so I'll use that. Let's sub. Yeah, it might have been. Could have said R is. Yeah, whatever. Sub 1 into 2. And we get 8 fifths equaling. So the T1 value, the T1 is now 10 brackets 1 minus R times R to the power 1, and it has to equal 8 fifths. Let's divide both sides by 10. Eight on 50, that's the same as 4 on 25. So we're going to get a quadratic, minus R squared. The question says, show that there will be two solutions. Well, you should be expecting that if you've got a quadratic. You could divide through by minus 1, or multiply through by minus 1, or we could even, because we've made this equal to 0, or what if we said 25 squared, R squared, minus 25R, plus 4. Now at this point, it's a quadratic formula job, right? So we could say R equals minus B. I don't know what's going to be easier, maybe this one. Minus B plus or minus the square root of B squared, which is 625, minus the 4AC. On the 2A term, which is 50. So we'll get, there's a half there, plus or minus. What do we got here? Minus 4. That's minus 100 times 4, minus 400. So you've got square root 225, which is 15. you've got your R equals a half plus or minus 15 on 50. That's a half plus or minus. These both divide by 5, right? 3/10. So you're going to get, therefore, R will be 8/10 or 2/10, which I should really write as 4/5 or 1/5. That was a bit of work. I think the way that I would do this, if I was in a test, I would probably just use my calculator for all of that. Let's say we left the quadratic like in this form, right? Just clearing some space because I'm going to the calculator now. Hopefully you can see the screen okay when I do that. Calculator. Let's clear that. We'll go apps, apply smalt 2, polynomial root finder, our order is 2. Next we had an r squared, and we had a minus r. I can't read it. Minus r and a plus 4 on 25, so that's going to be minus 1r, and then it was plus 4 divide 25, and then you could solve, and we should be getting, what was it, 1/5 and 4/5. Yep, there we go here. Right. So that would be perfectly acceptable way to find those solutions for R. Okay, R equals 1/5, or it could have equaled 4/5. So there's two solutions. That's what the question was saying. It also wants you to find term 1. So if R equals 1/5, T1 would be 10 brackets 1 minus 1/5, which is 4/5, which equals 8, right? And if R equaled 4/5, then T1 would equal 10 times 1 minus R. 1 minus R, well, R is 4, so it's 1/5. 1/5 of 10 is 2. All right, so that's fairly simple, that last bit. And I think that answered everything. Show there are two possible series. Well, we got two possible R values. Find the first term and the common ratio in each case. Done.